let's start.
All right.
First thing we're going to do is review what we've done before for e to the x.
E to the x.
Right, e to the x is very special because derivative of e to the x, it's going to be itself. So integration of e to the x will be itself.
Yes.
And plus a constant c.
Yes.
Right. However, we can change the exponent to be any number or functions we want. Let's say I change to be 2x. Now we cannot use e to the 2x itself because we have to consider we have a function right here as our u. So that's going to be e to the u dx. Right. So whenever we have u, we have to try to find u prime in front. We have u prime. Now this is going to be e to the u plus a c. So we follow this idea that we have to first get the u prime from 2x. So the u is 2x and the derivative of the 2x is 2. So we are missing the 2. We're going to make it half. Put the 2 in front. Now we prepare the whole thing to give us the final answer, which is going to be a half. And the e to the u, so our u is 2x, e to the 2x plus the c. That's it. That's what we done before. We also discussed one problem before is when we have a function which is e to the x squared. It doesn't really matter to what we have. We always set up our exponent to be our u. Our u is x squared. Now u prime is 2x. We do have x in front. So the only thing we're missing is the 2. So we make the half to have a 2. So now I have my u prime e to the x squared dx. We're going to follow our new formula right here to use the u. So that's going to be a half e to the x squared dx. That's it. Everybody good so far? Right, that's just a review of what we've done before. Now our new topic will be if we have x in front right here. If we have x in front, we are getting in trouble because how can we do the e to the x? Without x, we are able to do e to the x. However, we have x in front right here. We are trying to get rid of that. If we can get rid of x, we can do integration of e to the x, right? So in order to do that, that's our new topic today. We will do integration by parts. The integration by parts is the formula we're going to follow. So the formula gave us integration u e v equals to u times v subtract v du. Okay. What we are doing today is we just follow this formula to see if we can apply this formula to solve this problem. Then we verify if our answer is correct or not. Right. So let's look at our formula one more time. So the formula has to starting with u dv. So it's your job to apply u dv by yourself. That means we have to give something to be u and we have to give something to be dv. So what are we going to do the u? As we done before, u will take derivative. All right, so let's say I have u equals to x. Then my du will be dx. This is our u substitution we done before, right? Take a derivative on both sides. That's going to be du equals to dx. Now think about it. If I'm doing that, my x is going to be gone. That's what we're looking for, right? I want to get rid of the x. So I'm able to do e to the x by itself. Now let's look at the dv. We have to give something to be dv. So we're going to assign everything here to be our dv. See, because I gave u to be my x, the rest has to be dv. So now our dv is e to the x, e to the x dx. We have to get what a v is. So how can we get a v? Of course, this is our new formula. Let's verify if what we're doing here is correct. In order to verify, we're just going to take a derivative to see if I can get a function x times e to the x back. If we can get it back, that means what I'm doing right here is correct. Right, let's do that. So that's going to be e to the x times e to the x subtract e to the x. So we take a derivative of that. So this is a function times a function. We're going to use product rule. Right, product rule is take a derivative of first term. First is x plus take a derivative of the second one minus e to the x. So derivative of x is 1, so I'm going to get e to the x plus x times e to the x, because derivative of e to the x is itself. Subtract e to the x. Now e to the x cancels out. Now I get x times e to the x. That's exactly what we had before. That means our integration is correct. That's it. So far, so good? Everybody say that we are using a special formula right here, which is integration by parts, to get rid of x in front. So we are able to finish it. So it doesn't mean we always have x, right? We could have anything in front. It's your job to figure out what is the formula you're going to use in the future. So let's do one more example to see how the integration by part will work. So let's say I have same problem, same function, but I just change not e to the x anymore. Right now is x squared e to the x. Let's look at this problem right now as an exam problem, right? If I look at this right now, the first thing I'm looking at is, let's see, I say I have e. In order to use u to the x, I'm trying to find a u prime. But my u is x. X right now, prime is going to be 1. X derivative is 1, but I have x squared in front. Very bad. If I can get rid of x squared, we are able to finish it. How to get rid of the x squared? The method we just learned is integration by part. Now we're going to have one special example right here for integration by part. Let's start the same way we done before is which one you're going to assign for the u. That's very important. How do you think? Which one we should give to as a u? I want everybody to think about it. The one we done before is we assign x to be our u, right? How about this one right now? Integration by part is trying to get rid of something, right?
Mm-hmm.
Can you get rid of something by take derivative or integration? You have to think about x derivative becomes 1. So our exponent is decreased. Only when the exponent getting decreased, we are able to get rid of the function. Right? If I take u as my e to the x, it's not going to help because derivative of that, it's going to be itself.
Yeah, you're still gonna get it.
Right? So this is nothing we can do. It's going to be the same function again. And if I take an integration of this part, that's going to be increased because we use a power rule that's going to be x to the third over 3. Then we're making the front bigger. That's incorrect. So we have to put my x squared as my u first because I want to get this smaller exponent. So my u prime du equals to 2x dx, right? Because x squared derivative is 2x. Okay, now we're gonna cite the same way we done for dv. So our dv will be everything left, e to the x dx. Now I'm gonna do faster because I know the v, that's integration on both sides, that's gonna be v equals to e to the x. Okay, that's it. Now we prepare to substitute into our function, right? We have our u, we have our v, we have du, and now I have everything. So we're gonna substitute uv, that's gonna be x squared e to the x, subtract integration v is e to the x. Now we have trouble. Our trouble will be du. Du is, I'm gonna just copy first 2x dx. I'm gonna rewrite first because I want x in front of the e to the x. That's gonna be, I put 2 in front, x e to the x dx. Any questions so far? Right, I didn't do anything. What I just did is basically do the same way we done before. Nothing is new, right? Because I just set up my u, my v. I set up u and dv. Now I get v du. I substitute back into our formula. However, what's happening right now is I haven't finished it because I still have integration of x times e to the x dx. Can anybody help me right here? So my question, can we finish this right now?
Yeah, we just solved that integral.
We just solved, right? We just did this from the first example. What does this problem tell us? How many times I have to do it? How many times I have to use integration by parts?
Depends on the degree of the exponent in front of the e to the x.
Depends on the exponent, right? Depends on the variable we have. This type of problem, well, depends on x squared right here. If it's square, we do 2 times. If it's x to the third,
3 times.
probably gonna go 3 times. Fourth, then we have to keep on more and more. But the way we're doing it is always apply the integration by parts. Okay, everybody's good so far?
Mm-hmm. Yes.
Okay, so now so I don't have to continue right here, right? So let's switch to a different type of problems to see if the problem we should use integration by part or something else? Okay, let's look at it. So we just did, last week we did trig functions, right? Let's do one trig function right here. If I have an x, okay, let's say I have x times cosine x squared dx. Can I use integration by parts? It looks like the same format we just did, right? We have x in front, but we multiply a function. Remember, our first thing to do is always try u prime.
Yeah.
Right? So u prime is always our first method. If that method is not working, we try to use different ways to solve it. Okay. Can u prime here working here for this problem?
Yes.
So what is my u?
X squared.
X squared, right? Because we have inner function x squared. When we have trig function, we take inner first. Then u prime will be
2x.
2x. I do have x in front. We are missing the 2. We make it.
Yes.
I have my u prime right now. Then I have cosine x squared dx. Now what is the integration of cosine?
Negative sign. Oh, wait. Yeah, it's a sign. I always forget.
So integration of cosine is a sine. Right?
Yeah.
Okay, so that's going to be half sine x squared plus a c. That's it. That tells us it's very important. Doesn't mean we have x in front. That's going to be a integration by part, a problem. Right? It depends on how it's set up for us. Because sometimes one problem could be done by different ways. Integration by part is not for every problem we're going to have in the future. All right, it's only for a certain type of problems, which you're going to see more today. Okay, let's just change this a little bit. Let's change this one to be.
I have a quick question.
Yes.
So the x right before the cosine at the beginning of the question. So since the derivative of x is 1, that's why I just disregarded it and just moved on to the answer.
What do you mean by derivative of x is 1?
Yeah, so that's why I disregarded it and just went straight to the answer.
You jump to the first step. The first step, when I look at this problem, what type of problem we have right here? X, or it's a trig problem?
Yeah.
So which one is X or the trig?
Just a trig.
Trig. Okay, so there's nothing to, we are not even looking at X yet. I'm looking at my trig function here first.
Okay.
So the first is looking at the cosine. When we do the trig function, we have to see if there is an exponent for the cosine, or there's an inner function in the cosine, right?
Mm-hmm.
If it's exponent here, this is not a trig problem anymore. It's our power rule problem, exponential function problem. If it's inner, that's continue going to be our trig problem. If there's a power right here, we also discussed there's different ways to solve it. Right? We have trig identities. You do cosine x squared, cosine x to the third, cosine x to the fourth, right? Okay, so that's very complicated. But this one is pretty easy because our inner function x squared derivative is 2x. Basically,
Oh,
that
we have
helps
the
us
X.
to solve it.
Okay. Okay, I see it.
Okay.
Yeah.
Now we have a new problem. The new problem we have is x times cosine x. So now is what go back to you is when I have x inside here, I take a derivative, it's going to be 1. It's very bad because I have x in front.
Mhm.
I'm not able to take integration unless I can get rid of x, right? So how to get rid of x? We are thinking about using integration by parts because that's the way we can get rid of x. So in order to get rid of x, I have to set up u to be my x. So our du will be dx. And our dv is going to be everything I have left, cosine x dx. And what is my v?
Cosine x.
My dv is cosine x.
Negative sine x.
We just did the integration of cosine x. What is cosine x after integration?
Negative sine.
Sine x. No, just sine x.
Negative sine x.
Wait, did I say negative cosine? Oh,
No, negative what?
You said a negative
Oh.
sine x, right? Should be positive sine x. Right, so I basically jump one step right here because what I did is integration on both sides. Right, so variable on the left side is v, and the right side is sine x. Right, so v is sine x. Now we apply our formula. Our formula is x times sine x. That's u times v. Subtract v, which is sine x, and the du, our du is dx, so that's going to be dx. Of course, we are able to do the integration of sine x. So what is the integration of sine x?
integration of sine x.
Negative cosine.
Negative cosine x. So negative with the negative going to be positive. So that's going to be positive cosine x plus c. Okay. Just want to verify our answer. Right, so I'm going to erase the top. When I verify our answer, basically we also just review our derivative you done in calculus 1. So we're gonna do x sine x plus cosine x takes derivative that. So that's gonna be the product rule right here. I'm gonna do very quickly. So first is x derivative is 1 plus derivative of sine, that is cosine. Derivative of cosine is negative sine. So sine and a negative sine cancels out. The result will be x cosine x. That's exactly the function we're starting with. That's it. Any questions? So we have seen that x could combine with e to the x, and x could combine with our trig functions. Both these two types of problems have been finished by integration by parts. And we also say integration by parts may have to do many times. It depends on what I have in front. Right, everybody say that? I'm having x in front. If I don't have x, I have x squared, what's going to happen? Instead of x in front, if I have x squared.
Square. Then we have
You
to
have
do times.
2 times the integration by parts.
Why we're gonna use the integration by part 2 times.
Mhm.
Okay. Any questions so far? Right, so we don't have to do x squared. Right, that's gonna be your homework for next week. Now let's back to one problem we did before. We already used 2 ways to do it. Now let's do this third time. I hope you remember this problem, right? So we did 2 different ways last week. Now let's look at this problem right now. We are applying this. We are gonna use integration by parts. It doesn't matter which one you assign for u, right? I'm just gonna assign u to be my sine x. Now let's do our du. So our du is derivative of sine, that's gonna be cosine. That's gonna be cosine x dx. Now my dv will be everything I have left. That's gonna be cosine x dx. Now we're gonna take integration of that. We're just gonna be doing right here. That's gonna be dv integration of cosine x dx. Right, so that means my v equals to integrate cosine we just did. That's gonna be sine x. Okay. Now I think I have everything prepared. Now let's gonna be apply our formula, right? Look at your formula. That's gonna be u times v. U times v gonna be sine squared. Subtract. My v is sine, so that's gonna be sine x. Right here, I applied. Then I'm gonna get my du. Du is right here. Cosine x dx. Everybody see some problem we have? Do we have any problem right now? I think I have some problem. It looks like I'm getting back my original function. My original function is sine x times cosine x dx, right? But I having this again. That means if I continue, I'm gonna repeating having sine x, cosine x. Now this is infinity. We keep going, that's gonna be come back the same. Now we have to look at this very special. I have a negative sign right here. If I have positive sign right here, I can cancel out this term. But I have a negative. That means I can move sine cosine dx to the right side or to the left side. I'm gonna add in the same term right here on both sides. If I'm adding that, I'm double the same term on the left side right now. That's gonna be 2 equals to sine x squared. This is 2, so how many we want? We just need 1 because that's our original problem. Our original problem just need 1. So we're going to divide by 2. Now I just have 1. Now I solve it. So now I solve by integration by parts. What happening is when I solving this problem, I'm getting the same problem come out with negative sign. When this happening, you should stop your integration by parts by solving it using the idea about moving to the left side and divide by 2. Right. So if you check our answer before, this is one of our answer we did before, which is sine square over 2 plus c. Any questions so far? Everybody's good?
Maybe. Can we
I just
do it?
want to make sure everybody understand, right? Understand how we apply the integration by parts.
Wait, so if you see that's going to be a loop, then you just subtract to cancel one side.
I didn't subtract, I adding.
You added to cancel one side.
You're right. But after I adding, I basically get my original problem,
Yeah.
right? I double the original problem. And double that meaning is you divide by 2, right? We just need half of it. Okay, that's the whole idea. So whenever you get your original function back, you should do this way, right? So now we see 2 different ways of solving integration by parts. One possible is we continue do it until we finish it. So that's applied to the problem we have x to the third. We do 1 integration by part, will give you x squared. We do 1 more, will give you x. The last one we do it, we done. This is different type of integration by part. Is there's infinite integration by part. If you continue to do it, right, you're gonna keep on getting sine, cosine. So in order to stop it is whenever you say you have the same, you stop. And the sign must be negative, otherwise you're not gonna be able to move, right? Something gonna be, you made a mistake, right? Sign is very important. You have to have a negative sign so you can move to the left side, okay? Any more questions?
I think I got it.
Everybody's good so far?
I think.
Or you want more problems, or everybody's fine?
We can do another one, I guess.
Okay, let's see. Let's do something we've done before. Because as I said, a lot of problem we are able to do different ways, right? The idea is we want to get rid of something. The integration by part is able to help us. Let's look at our first exam problem we did. First exam, we have something very similar to here, x times x plus 1. Anybody remember this problem?
Yeah.
Right, something similar. I mean, not exactly the same. I think our problem is harder than this one, but the way we did is, or what have we done before? Can we do u prime first, right? So first I try u prime. It's not gonna work because when I set up u to be x plus 1, the derivative of that is gonna be 1, but we have x in front. No good. If I can get rid of x, we'll be able to solve it. So the way we done before is we gave a u to be x plus 1.
And then we make a du. Well, we shift.
Then our du is
Is
dx.
dx, yes.
Right. So what is our x?
X is u minus 1 over.
X is solving by here. That's going to be u minus 1.
Minus 1, yeah.
Right. So we do the basic u substitution right now to solve that. So now we're going to have x is u subtract 1 times square root of u du, because we're going to change everything to be u. Now we can do the distribution here to have u times square root of u minus square root of u du. Now we have no problem here because we can combine. So we have no problem here. So this problem solved. So we solve this by using the u substitution. Right? So it's not very hard problem to do by u substitution. Now let's say can we do integration by parts? So when we do integration by parts, very important. Which one going to be our u? Which one going to be our dv? So if I have this by itself, we know how to do it, right? That means I want to get rid of x. In order to get rid of x, I should set up x to be my u. Our dv will be, I'm going to write as exponential function form half dx. Right. Maybe this is not easy, but we just want to try this to see if integration by part can also solve this problem. Okay, now let's do du. That's going to be dx. And the v going to be equals to, that's exactly what we're doing right now. Take the integration of that. My inside derivative is 1, so that's good. So that means that's going to be a half plus 1. I'm going to do it 3 over 2. 3 over 2.
What's this? Yeah.
Okay. Everybody's good so far? Right, I just take a derivative of that, so that's what I get. It's kind of complicated, but let's just keep on going. So now I'm going to apply our formula. Our formula is u times v, so that's going to be x times, I'm just going to copy this. 3 over 2, 3 over 2. Subtract. And my v is the same, this one, so that's going to be x plus 1, 3 over 2, 3 over 2. My du, that's going to be dx. I just copy it. We just need to take a look. Is there any problem for us to do the integration here? Our second term right here. Any problem here?
No.
We don't have any problem, right? Because this is the same as we have a half. I just have a bigger exponent. That's going to be just adding 1. That's going to be 5 over 2, 5 over 2 in the future. So this part we are able to solve. That means we done this by integration by parts. So how do you think which way is easier? It's up to you, right? On the exam, you show me how you do it. And the homework problem for integration by parts homework problem, of course, you have to use integration by parts. For the exam, it's your choice to use the way you think is better. But remember, not every problem is integration by part problem. right? Sometimes you try it, you're gonna waste a lot of time because you have to understand what's the best method to use. Okay. Any questions?
No.
Any questions?
I guess no.
Okay, so if everybody's fine, we're gonna stop right here.
Right.
Right, we just show you how this is gonna work. If you need more examples, I can do more videos for this topic. Then we're gonna have one homework for next week for this. Then for our lecture next week, we're gonna continue doing the trig integrations. Okay,
Okay.
if you have any questions, stay, otherwise that's for today. Okay, so I'm gonna stop right here.
All right. Got it.
Good question. You said
Sure.
if a person does good on the first and second exam, they don't have to take the last exam, right?
Right now you have to.
Right now you have to.